Chronic obstructive pulmonary disease, COPD, is a group of lung diseases that presents with two main phenotypes, chronic bronchitis and emphysema. It causes gradual irreversible damage to the lungs. COPD has an estimated yearly cost of $50 billion and is the third leading cause of death in the USA. A core tool used in COPD diagnosis, spirometry, is error-prone. Dr. Stein Handgaard, a leading researcher in this field, has demonstrated that spirometry values can vary based on training and other variables, which does not make the process consistent and objective. Fortunately, there has been an increasing trend of physicians ordering imaging studies for their COPD patients to further supplement the diagnostic protocol. CT scans do provide more accurate understandings of the severity of COPD, but they also have their own issues. Lung motion is quite dynamic due to respiration. As such, we cannot compare lung scans across time or patient without first establishing a common frame of reference. Registration is the process of spatially aligning two images of a particular anatomical location. The two figures to our right demonstrate the necessity of registration given the slight anatomical shifts in lung position between the first and second scan. The two main types of registration are rigid and deformable. Rigid registration involves computing a linear spatial alignment, whereas deformable registration involves computing a nonlinear alignment. As the figure below shows, we have two scans as input, the floating image and the reference image. The floating image is fed into the registration model, and the model outputs a deformation field. In simple terms, this deformation field allows us to change the coordinates of the floating image so they align with the reference image. Hence, the floating image is aligned with respect to the reference image, and we call this the transformed image. Now we can use this transformed image for any kind of downstream analysis. In the COPD field, potential downstream tasks could be forecasting potential exacerbations, which are life-threatening acute flare-ups and symptoms. Clearly, there is much value in being able to predict such adverse events. So, radiologists need a method to extract biomarkers for same-day updates of the patient's condition to their pulmonologist in order to minimize the burden of care for COPD patients. After discussion with our radiologist collaborators, they would like to see a model that is fully automated, handles large batches of scans, is accurate, fast, and can integrate with an end-to-end biomarker pipeline. We measure accuracy by the DICE score, which is simply a metric to compute image similarity, and measure speed by computational runtime. We propose to use a generative adversarial network, a type of deep learning model, to register CT scans. There are two key parts to a GAN, a generator and a discriminator. The generator takes the reference or fixed image and floating or moving image as input, and then computes the deformation field and transforms the floating image to align with the reference image. The discriminator then computes the accuracy of the registration. Our model is better than current solutions because we can register multiple pairs of scans at once, estimate more complex deformations, which is needed due to the complexity of lung motion, does not require significant computational resources after initial training process, and it can be integrated with the biomarker pipeline. So far, our current prototype, DIR GAN, also deformable image registration GAN, has successfully shown proof of concept in the 2D space. We've successfully registered 2D retinal fundus images. We are currently working on solving the problem in the 3D space with COPD CT scans. Below each figure panel of the warped fixed moving image, that is the deformation vector field needed to warp the moving image to align with the fixed image. Thank you.